begin with, the first and most important part about the proof is to be able to clearly state exactly what it is that you're setting out to prove. Next, we need a drawing. Typically, in a formal proof, the drawing is not necessarily provided, so you should create your own drawing representing the hypothesis of the theorem. Once we have clearly stated our theorem and drawn the situation which represents the hypothesis, we should rewrite the given using our drawing and any figures which we have labeled in our drawing to clearly state exactly what the given information is. Having stated the givens using the drawing and hypothesis of the theorem, we will also state the prove statement. Finally, we must write our formal proof of the theorem. This seems like a lot of pieces, but let's see how they all fit together in action. We will prove the theorem. If two lines are perpendicular, then they meet to form right angles. First, we must clearly identify our statement. In this case, it is simply rewriting the theorem we are proving. Next, we draw the hypothesis. In this case, two perpendicular lines meeting. We have lines AB and lines CD, intersecting at E. We then restate the given information from the drawing. And we also state what we are setting out to prove. In this case, it will suffice to prove that the measure of angle CEB is a right angle. Now we must write our proof. In a formal proof, it is most common to write the proof in the form of a paragraph proof. We'll be representing that in the example here today. We begin by restating the given, and also adding the definition of what it means to be perpendicular in context of the picture that we have. It is very common in any proof to move back and forth between the meaning of congruent shapes and how that translates to the length of their respective measures. Our goal is now to use the fact that the measures of those angles are equal in some equation. Where we get that equation is the angle addition postulate. Since we know that the measure of the two angles is equal, we can do a quick substitution in order to simplify the equation from the angle addition postulate. Using the fact that we have a straight line, we can represent the measure of that angle as 180 degrees, whereupon one more substitution yields us the equation that the measure of angle CEB is in fact 90 degrees. A final application of the definition of right angle, and this proof is done.